All right, we're on chapter 7.4. Everyone there?
I wake up at 6:30 and I really finish just missing math.
All right.
Ryan need to do like I send you a project of the candles.
Yeah. All right. We'll talk about that afterwards. Let's get started.
Sure, you never tell me what I am missing.
Yeah, I didn't have time. Okay, let's get started. We're going to talk about the 8 planets in our solar system. Does anyone know who the 9th planet was? I think it's a planet now. It used to not be a planet. Does anyone know what the 9th planet was? Anybody? The coldest planet? Farthest away?
What page, mister?
188.
Neptune.
What's our Neptune? It starts with a P.
Plural.
No.
It's plural.
Pluto, yeah. No, Pluto. It's not in here. It used to be a planet. Not anymore. All right, let's keep going. The 8 planets. Among the most spectacular objects in the heavens are the planets. Most shine more brightly than the stars. The planets, however, are not luminous. Like the moon, they reflect the rays of the sun. So, the 4 small planets closest to the sun, Mercury, Venus, Mars, and Earth, are called the inner planets. Scientists believe that all of them are made mainly of rocks and metals. Earth is the only one with a liquid mantle surrounding its core. The outer planets are Jupiter, Saturn, Uranus, and Neptune. These planets are much larger than the 4 inner planets. And instead of being made out of solids like the inner planets, the outer planets are composed mainly of liquid and gas. In the past, very little could be known about these 4 planets because of the great distance from Earth. But since 1972, the United States has launched Pioneers 10 and 11, Voyagers 1 and 2, Galileo, and Cassini, unmanned spacecraft designed to send back information about the outer planets. From these probes, we have learned and continue to learn many new things about the most distant members of the solar system. So we would send probes, or just kind of like spaceships that didn't have people with it. And they would take photos, they would take samples. Like we have a little robot on Mars right now, so we can get like examples of what it's like on Mars and stuff like that. So that's what it's talking about. That's what the probes are. Pioneers 10 and 11, Voyagers 1 and 2, Galileo, and Cassini. All right, let's talk about the inner planets. Monse, I want you to read first. Mercury.
Hey, mister. The inner planet. Mercury. Mercury is the closest planet to the sun. It orbits the sun very quickly, taking only about 88 Earth days to complete one full revolution. Not much larger than our moon. Mercury is covered with craters and has no water on Earth. Because Mercury has no atmosphere to hold in the sun heat, temperature difference on Mercury are very great while the sun bakes one side of the planet. Of daytime temperatures up top. 997 in Mr. How is that?
997
Fahrenheit.
Fahrenheit. Fahrenheit.
Other side of the planet faces through a frozen night in which temperatures plummet to 275. Venus, I read that one too, Mr.
No, we're gonna stop right there. Okay, so opposites are there. When the daytime temperatures is 797 degrees Fahrenheit, we would die. And the nighttime, it's negative. You see a little minus sign? Negative 275 degrees Fahrenheit, which means super cold. So the only way we could live there is if we had some sort of protection. But I doubt we would. So it gets super hot, super cold. Because it is the closest to the sun. All right. Let's go with Sander. Read me Venus.
Venus. Venus, the brightest planet in the sky, shines with a silver glow. God must have intended Venus to be and especially brilliantly in the heaven, for he wrapped the planet in a blanket of unique clouds. Almost like a mirror, these clouds reflect over three-fourths of the sunlight that falls upon them. Because the Earth and Venus are neighbors in the planetary system and because they are of about the same size, they are something called twin planets. In the past, astronomers often wondered about what lay below the thick clouds of Venus. They imagined a world similar to ours, here exotic planets and other forms of alien life flourished. But now we know that it would be impossible for living things to survive on Venus. The majestic clouds are thought to be composed of water vapor are actually formed from sulfuric acid, a heavy atmosphere of carbon dioxide bear down on the great temperature of the air on time. The clouds atmosphere trap the rays of the sun and produce temperatures above of 850 at the surface. The planet has no water. Is Venus really much of a twin to Earth?
All right. So we have Venus there, which is the brightest planet in the sky, and it's the twin planet of Earth, but they're not really the same. Not at all. It'd be impossible for things to live on that. They have really thick clouds composed of water vapor, but they're actually acid, which means something that'll kill you if you don't. All right, let's go with Lizzie. Read me Earth.
Earth. Viewed from space, Earth looked like a huge blue sapphire suspended in the heavens. This sphere of such inviting beauty is the only planet in the solar system that is suitable for life. God positioned Earth just the right distance from the sun to make certain that the temperatures on Earth could be tolerated by living things. In Earth's atmosphere, he includes the oxygen needed to sustain life. He also blessed Earth with a bountiful supply of water. As he studies all the various planets of the solar system, we can certainly gain a greater appreciation for Earth, the comfortable and hospitable planet God created to be our home. It continues.
Let's stop there. This is the only planet that has life. The only planet that can survive. And things can survive on it. So this is perfect that God made for us. Yeah. Keep going. Let's have Carlos, read me Mars. Carlos.
Okay, me. I can hear good. What?
Wanna read?
What?
Wanna read Mars?
Okay. Wait. Okay. On many evening, a viewer from Earth can see Mars, the red planet, glowing with a strong reddish light. Mars is about half the size of Earth, and it was two small, lumpy-looking moons.
Like Venus, Mars is a planet on moons. Like Venus, Mars is a planet on which scientists hoped to discover signs of life. In 1976, the unnamed spacecraft Vikings IN-2 landed to Mars and began taking photographs. These two craft and the other orbiting space rovers have shown conditions on Mars be rather unfavorable to life. Rocky wind swept desert of reddish sand along with deep canyons, large craters, and towering volcanoes cover the surface of the planet. The atmosphere, mainly carbon dioxide, is very thin. Temperature on Mars range from about 225 F to 16 F. No life in any form has ever been discovered.
So it's more possible that we can find life on Mars, but no, we haven't found it yet. Any chance, but no. Let's go with Gloria. Read me Jupiter.
Jupiter. Beyond Jupiter, the large planet in our solar system is large enough to slow one 300 planet size of Earth. Jupiter is clearly visible from Earth with a unaided eye. It is the most colorful planet in the solar system. Its atmosphere swirls with red, cream, orange, and brown clouds. Swift wind currents weave these colorful clouds into bands, eddies, and swirls. Spiraling in the midst of Jupiter clouds is the gray-red spot, a rotating storm very similar to a hurricane, except much more enormous, with a diameter nearly 3 times greater than the diameter of Earth. Hot thunderstorms sent for light night bolts with power the thousand times that of light on Earth. Although the temperature above the cloud is negative 250 beneath them at the planet's core, the temperature is a crunch in 5000 in 1979. The Voyager 2 spacecraft allowed the scientists to discover for the first time that Jupiter is encircled by a system of buried rings. At last 16 months also orbit the planet.
All right. Amelia, do you want to read next? Saturn.
Bueno, you're next, mister.
Saturn.
Okay, Saturn. Saturn is the second largest planet. Like Jupiter, it's a hot gaseous global grappling layer of heavy cloud, having bands of red Saturn had its equator. Each green band is made of thousands of times 3
gets formed from small piles of orbiting things, ice, and rock. Saturn also has a list of distinct moons. One moon, Titan, is larger than Mercury and has its own almost third, almost, almost third.
All right, so this is Saturn, which is the second largest planet. It has 7 bands of green surrounding Saturn. It's a gold. Pretty cool. Seeing it. Um, and it has at least 60 moons. We have one moon that has at least 60, and one moon, Titan, is larger than Mercury and has its own giant. All right, let's go with Benya. Read me Uranus.
Uranus. On March 30, 1781, Sir William Herschel, a great English astronomer, became the first man in modern times to discover a new planet. When he discovered Uranus, 4 times the size of Earth, Uranus is the third largest planet in our solar system. Since the sun rays must travel 1,784,000,000 miles to the reach Uranus, the planet is very cold, about -350 centigrade. Believe that Uranus' cold, dense atmospheric gases thousands of miles deep, conceal ferrous and ocean of liquid water. Compared a solid core the size of Earth, one unusual thing about Uranus is that it is tipped over on its side, with its poles pointing directly toward and away from the sun during the summer and winter seasons. 27 moon and 13 dark rings over orbit Uranus.
All right, and John Carlos finished strong with Neptune.
Hi, Mr.
Good.
Neptune.
Yeah.
Far off in the distant reaches of the solar system, Neptune journeys in a lonely path around the Sun, taking 185 Earth-years to complete a nightly revolution in its orbit. Because it is so far from the Sun, over 2,000,000 miles, Neptune was not discovered by astronomers until 1865. Scientists believe that, like Uranus, Neptune consists largely of liquid water, comprising a vast ocean thousands of miles deep. Neptune has a zinc-like, peaceful royal blue atmosphere. Despite its appearance, however, Neptune has the strongest winds measured anywhere in the solar system. Driven by the wind, the clouds on Neptune's surface curve around the planet in several hundred miles an hour. On Earth's side, the storm, called the Great Dark Spot, spun its way through the planet's atmosphere until 1994, when it completed its phase. 13 moons and 5 rings circle around Neptune. One of the Neptune's largest moons, Triton, has an magnetic field and a very thin atmosphere. Triton's temperature is the coldest so far measured anywhere in the solar system. 390 F of Triton surface about liquid nitrogen and much as 5 miles to the atmosphere.
Very good. All right, so we got our 4 planets. They're called the inner planets, which are what? Who can tell me the 4 inner planets? Give me one.
What, mister?
What are the 4 inner planets? Don't say which one did you read?
Saturn.
No, that's Saturn.
What do you say?
The inner planets, the 4.
I can listen.
Mr. Busayo, one is Mercury,
Mercury's the first one.
Venus,
Neptune is not one.
Venus,
Mars.
Mars,
Mr. Venus,
Earth.
Jupiter.
Earth. We have the 4, which is Mercury, Venus, Earth, and Mars. What are the 4 outer planets? The giants.
Jupiter,
Saturn,
Uranus, and Neptune.
And Neptune.
All right. So we'll go over these guys real fast. We have Mercury, which is the closest planet to the sun is Mercury. Then it's Venus, which kind of looks like Earth. They call it Earth's twin. We have Earth, which is the only planet that has a system suitable for life. And Mars, which is the red planet. After that, we have Jupiter, which is the largest planet in the solar system. Then we have Saturn, which is the second largest planet that has rings surrounded at its equator. And then we have Uranus, which is the funniest planet. I have to, do you guys know why it's funny? No? It is the 3rd largest planet in the solar system. And it has a lot of gases. And then we have the last one, which is Neptune. After that, we used to have Pluto, but Pluto's no longer there. Let's go to 193.
Mr. I already do it and I already finished.
All right, we're going to move to
You.
193 now.
Mister, how many comprehensions we will do? Just 2.
Comprehension check 7.4 and 7.5, mister.
Thought about having you guys do 7.6, but
Mister, we need to do a project here.
no, you don't have to do it. All right, here we go. The miracle of air. In the beginning, God made the earth and sent it spinning through space. As the earth whirls through the heavens, it at first appears to be a rather insignificant traveler among the huge and radiant stars. But the earth is the most important part of God's creation because it is the planet he designed to be the home of living things. If you had something very precious and wanted to send it on a long journey, you would probably wrap it carefully to keep it from being damaged. So God, the good creator, has placed around his earth a protective wrapper called the atmosphere. We're going to learn about the atmosphere now. What is air? The atmosphere is a mixture of invisible gases. We call this mixture air. Like tiny skaters in an enormous rink, molecules of atmospheric gases dash about frequently, encountering and even bumping into molecules of other gases. The molecule skaters do not always move at the same speed. When air is heated, molecules move around quickly and push each other apart. The air expands or takes up more space. The air is cooled, the molecules move more slowly and huddle closer together. Then the air contracts or requires less space. But the molecules do not squeeze together so much that they join to form a new type of molecule. The molecules of each gas remain separate. So when it heats up, it separates and moves fast. And when it's cold, it contracts and stays slow. Most air molecules are molecules of nitrogen, which make up about 78% of the air. Oxygen is another 21% of the air. In addition, there are small amounts of carbon dioxide and several other gases in the air. Besides gas molecules, all air contains particles such as dust, salts from the sea, volcanic ash, ice crystals, and pollution. Air also contains water vapor. As you learned in chapter 5, water vapor is put into the air through evaporation from the ocean and other bodies of water. All right, why is air important? Who's going to read it? What's going on? Where's everyone leaving? Lizzie left. Who else left?
What is air? The atmosphere is a mixture of invisible gases. We call the mixtures air like
Senya. Read page 194.
What is air important? You are well aware without air for even a few seconds can be a rather unpleasant experiment. All living things need to gas in the atmosphere in order to exist. People and animals use oxygen when they breathe, and plants use carbon dioxide in the process of photosynthesis, through which they make their food. Air does many things for us besides enabling us to breathe. However, without air, we will not be able to hear because sound waves travel through air. Air also helps to give us fresh water to drink. When you study the water cycle, you learn that water must be put into the atmosphere before rain or other forms of precipitation can fall on the earth. In addition, air helps to warm the water. After the sun energy reaches the earth, much of the energy is sent back toward space, but it does not all escape from the atmosphere. Some is trapped by the gases in the air, especially by carbon dioxide. More of the energy absorbed by carbon dioxide is sent back to the Earth's surface and cold to make the world a warm, suitable place for life to exist. One of the most important things Earth does is to protect the Earth, only part of the sun relation with the Earth. Many harmful rays that could destroy life Earth are blocked out by the gases and cloud the atmosphere.
Very good. So Earth helps. Where's everyone going?
Mr. Water 6 here. We lose the half.
I know.
Mr. Why everybody go out?
We're missing Emilia.
Why is everyone going?
Mister, where we are is because my Wi-Fi go.
Xander left. Lizzie and Emilia. They don't send me a message. You're gonna be in trouble.
My Wi-Fi is good, mister.
194. What is the atmosphere like? Layers of the atmosphere. Carlos, want to read that for me? Your microphone, bro.
I can hear you.
Read that one. Your microphone was off.
Wait. And what is atmosphere like?
Yeah.
Okay. Layers of atmosphere. Have you ever heard anyone ask how high is the sky? You could probably travel 900 miles above the surface of the earth before leaving the atmosphere. Actually, the atmosphere is not just one protective vapor, it is a series of layers stacked on one on top of another. Is the past scientists try to study the upper layer of the atmosphere by sailing up with huge hot air balloons. These brave researchers ran many risks to study the atmosphere. Some almost died when their balloons rose above the level where there has enough air to breathe. Today, modern scientists can observe the atmosphere more safely by using airplanes, satellites, and spacecraft. In section 7.6, You will learn how each layer of the atmosphere helps to protect the Earth. For now, study the diagram on page 197 and learn names of the atmosphere layer as well their thickness.
All right, I'm gonna read it to finish it off, okay? Good job. Air pressure. Because Earth's gravity pulls on the air in the atmosphere, 75% of the air is packed down into the bottom layer. So the majority of the air is at that bottom part where we're at, the troposphere. And half of the air is below 3 miles. All but 1% of the air is below 20 miles. God has designed the Earth with the exact atmosphere needed to support life. Our air does not float away into outer space, neither does it push down on us so hard as to crush us. Imagine being crushed by death by air. Because of God's wise design, air does not press upon us that hard. It does press down upon the surface of the earth harder than you might suppose, however. The total weight of all the air in the atmosphere is approximately 5,600 trillion tons. Air pressure is the total weight of air on some particular place on Earth. At sea level, air pressure is almost 15 pounds per square inch, more than a ton per square foot. At this moment, you may have 10 tons of air weighing upon you. If you are at sea level, you are not smashed to the shape of a pancake by all that air because God has designed your body so that so that pressure inside you pushes out, equalizing the pressure of the air. If you could sail through the air in a balloon, you would find that air pressure gradually decreases as you rose higher and higher. Can you explain why? The higher you went, the less air there would be to press against you. When you sailed past the top of a high mountain, about 18,000 feet, air pressure would have decreased to half of what it has been at sea level. All right, so that's air pressure. That's what we're gonna learn about. I'm gonna be nice to you guys.